What is up, guys? In the last video we went ahead and talked about decision trees, and in this video we're going to be talking about the random forests which use decision trees to make certain predictions or to classify objects. And to get started, I went ahead and prepared a very simple diagram that tells us how it works essentially. So just like in the decision tree, we have some inputs such as a high price and a high score for a certain wine. And what the random forest does is generate a bunch of different decision trees in different orders and then takes the outcome of each and it then makes the decision based on that. For example, here is the first decision tree that has the price, and since the price is high, it says no, we will not buy the wine. And then we go to the second decision tree that it generated and it says the score is high, so let's buy the wine. And then we have a third decision tree that says is the price low? And it's not a low price, so we will move on to the next statement. And is the score high or low? And since the score is high, we went ahead and clicked on yes. So random forests can have hundreds of trees, thousands of trees, or even just 5 trees. It really depends on how many you want to insert. And based on that, it will generate many different trees that will try different combinations, and they will give you different outputs to maximize the distribution. So for this example, with these 3 decision trees, we get the output of yes because 2 were yes and 1 was no. And that's the basic idea behind the random forest. Now we're going to be using the same program from the decision tree, except this time I went ahead and created a CSV file because this is a lot easier to maintain and a lot easier to insert your values. So inside here, all I did is went ahead and expanded what we had earlier. So as you can see here, we only had 6 of each, but now in the CSV I expanded that to be 10 of each. So I'm going to leave this in my GitHub repository in case you want to copy that, but the concept is the same. We have red and white wine, and the price is high and low. The score can be high or low, and based on that, it's going to give us an outcome of whether we bought the wine in the past or not. And we can go straight to the project that we had from last time. But inside here, the first thing we're going to do is import from sklearn.ensemble. We're going to import the random forest classifier. And this time it's going to look a lot cleaner. So all we have to do is remove the raw data, and our data frame is going to equal a read CSV. And you need to locate where your CSV file is. The easiest way to do that is to right click on it, click on copy, and copy the path. You might have to copy the absolute path, or you can also just try it out if it's in the same folder. Just go inside here and type in sample wine data.csv. But since the parameters or the keys are all the same, we do not have to change anything from what we had earlier. So the wine, the score, and the price and bot all stays the same. Translation can stay the same as well. And now we can actually go to what we do need to modify. And as you can see in the last video, we created a decision tree classifier. This time we are going to edit that. So we will also have the random forest classifier, so we can also compare the scores. So for this one, we're going to go ahead and type in clf, which stands for random forest classifier, and that's going to equal a random forest classifier. And inside here we need to provide a number, which means how many trees do we want to generate. And for this example, we'll go ahead and generate 10 different trees. Then we should also fit this data. So right under the old one, we're going to go ahead and call rf and type in fit with x and y. And again, use your training data if you have training data. I still don't believe we have enough examples to make it worth it. But if you do have hundreds of examples or hundreds of values to process, go ahead and insert your training data. Then we also want to print the score for each one. So the first one will be the score from our decision tree, and we'll just call this tree. Then we can just go ahead and duplicate this. And the second one is going to be forest. Of course, we need to also edit this to become a forest. So rf.clf.score, and this should print the 2 scores. And that's actually all we had to change in our decision tree project, which means all we did is add the random forest classifier, and we made sure to fit the data, and we also decided to print the score this time. And of course, we also changed the data a bit with our own CSV file. But now we can go ahead and right click and run this program. So you're going to notice that it is going to give us an accuracy of 0.75, and it's going to say we buy the wine. That is, if the wine is red and the score is high and the price is low, we decide to buy the wine. Let's go ahead and type in high price and high score. And you're going to notice that we will not buy the wine for this one. Now, if we go back to our data, I can quickly explain why we get these outcomes. So let's go back to our CSV. And the reason we get a 0.75 is because a lot of these kind of clash together. As you can see, we have a high that leads to no and a high that leads to yes. And of course, this leads to a split in the chances. So our program calculated our answers to be to a 75% accuracy, in other words. But that's essentially how we get these scores. It actually goes, it can be a lot more complicated than this, of course, if you have hundreds or thousands of values. And finally, the last thing I should mention is whether you should use a decision tree or a random forest. And there's not really a set method for doing this because the decision tree is really good with small amounts of data and can be very, very accurate on small amounts of data. And the random forest classifier I saw was more prevalent in larger amounts of data. But sometimes that can be inversed, and it really depends on the data you're working with. So definitely go ahead and try both of them when you are deciding which one you should use. But I believe that's actually all I wanted to explain in this video. And if you have any questions, feel free to leave them in the comment section down below, and I'll do my best to look at them. Otherwise, thanks for watching, and I'll see you in the next video.